Chapter 16 Principles of Software Use in Qualitative Data Analysis. Amita Ray, Arshil Sabin. Abstract. Quantitative and qualitative analysis is akin to swimming in the pool as against the ocean. One may find swimming in a pool easier as the pool provides a structured environment where there is a labeled entry, exit, and a track to follow. This is what most medical education researchers are accustomed to with quantitative research. With its iterative and looping approach, qualitative analysis may feel like a dip in the ocean with multiple ports of entry, exit, and depths of analysis. Since the advent of computer-assisted qualitative data analysis, managing voluminous datasets with a variety of data inputs has been rendered a relatively less arduous task. In this chapter, we will introduce the reader to the principles of software use for qualitative analysis with examples and screenshots of the step-by-step process. Keywords: qualitative analysis, computer-assisted qualitative data analysis, assess need. Qualitative research is a methodological approach which aims to understand the participants' point of view and their social context on a given theme as interpreted by the investigator. Until the mid-82nd, quantitative research was considered the only reliable way of collecting data. Since 1977, Bardeen popularized a method of qualitative data analysis by content analysis. This had many advantages. However, certain challenges remain, like the lack of methodological rigor and difficulty in handling extensive databases. This need led to the development of software packages for assisting in QDA, which have since become widespread. Qualitative data refers to non-numeric information such as interview transcripts, notes, video and audio recordings, images, and text documents. Qualitative research in medical education usually answers the question how an educational intervention works, in contrast to quantitative research in medical science, which compares a medical intervention with another to ascertain which would give better healthcare results. Unlike quantitative analysis, it does not deal with numbers, rather it deals with themes and codes. Allotting codes and themes to qualitative data manually is a tedious and time-consuming endeavor. Since the advent of computer-assisted qualitative data analysis, managing voluminous datasets with a variety of data inputs has been rendered a relatively less arduous task. Another case for use of software in QDA is that it has demonstrated increased reflectivity in the researcher by increasing reflective consciousness. Reflective consciousness is the awareness that enables a person to reflect on his own activities. Reflecting on our own activities while doing qualitative analysis is essential to increase the robustness and rigor of the analysis. As qualitative investigators, we need to be aware of our contribution to the construction of meanings and of life experiences. Presently, there are dozens of QDAs available, and each of them have their own strengths and weaknesses. Having said that, most of them work on the function of descending hierarchical classification. In this chapter, we will introduce the software used for qualitative data analysis, focusing on the common workflow and procedures. Brief. After reading this chapter, the reader should be able to understand and emulate the following steps in the use of software for qualitative data analysis. Creating a project, importing data, understanding the workstation, creating quotations in the document, coding, categorization of codes and theme generation, querying the data, generating a report. It is important to remember that these steps do not necessarily follow a linear progression. CO and 3XTUAR rise in E. Madam Quantity in high-grade medical college is a medical teacher, a practitioner, and a researcher all rolled in one. She had done a lot of research in her own specialty and had 50 publications in index journals. Since she read about qualitative research, she felt that her resume would be enhanced if she could do qualitative research. So she chose a research topic and did 20 interviews of students. Having completed the interviews, Madam Quantity is deluged with information and does not know how to code, analyze, interpret, and document the results of her study. Describe the generic workflow in the CAQDAS is discussed below. It is assumed that the reader is familiar with preliminary glossary and steps in QDA. For the neophyte as well as the veteran alike, it would benefit to read the chapter on QDA preceding this chapter before starting with the software. Bear in mind that unlike quantitative, qualitative analysis does not flow from point to B and then to C. Barring few obvious exceptions such as grouping codes before coding, many steps in the analysis can be done simultaneously or one before the other. We will be using references to ATLAS.ti and NVivo in the chapter, but most other software doing QDA would have comparable features, and the generic flow of the analysis presented in the chapter can be used in them as well. Downloading the software. The trial versions of the software are available on their respective websites. At the time of writing of this chapter, ATLAS.ti can be downloaded from ATLAS.ti.com and NVivo from QCinternational.com. The installation is straightforward and mimics software installations like most other software. There are scores of other software for QDA and some of them are free. Expectedly, the free software has limitations in comparison with the paid software. Creating a project. Next is the creation of a project with a specific name which will store your data. This ensures that you have all the data in one place and the software is ready to help guide you to the next step. You might already have a project created in the software and want to work on it further. In that case, click on Open an existing project. Be sure to give a name to your project for an appropriate and easy identification. A helpful tip could be to periodically create a backup of the project in a secure location on your desktop to avoid loss of work. Importing your data. Now that you have created a project, the next step is importing all your research materials, including Word documents of interviews, focus group discussion, PDFs, datasets, audio, video, pictures, memos, etc. into the created folder. All data that you would like to analyze should be imported into this project. The supported formats are text://dot docx, RTF, ART, HTML, TXT, and XML. A plethora of transcripts prepared by transcribing. Software like Easy Transcript, F4 and F5 Transcript, Transcribe, Inscribe, Transonic, Express Scribe are supported. Apart from these auto-generated transcripts in SRT and VTT format from practically all sites are also import compatible with ATLAS.ti. Image, BMP, GIF, JPEG, JPG, PNG, TIFF, and TIFF. Audio file formats, OP, M4A, MP3, MP4, WAV. Video file formats, 3G2, 3GP, 3GP2, 3GPP, AS, AVI, M4B, MAV, MP4, WMB. Reference Manager Data and Note XML. When you click on the project icon, you will get the screen below and you can click on the import files to bring all your files which you require for the analysis. Figure 1. The dialog box for common studying options. Once you click on the import files, it will show you the files you have in your PC as below. You could select the one you need, or if you require several, you can press the control button as you would do for other computer processes. Figure 2. Document import screen. Overview of the workstation in QDA software. Each software available for QDA has a different set of features and utilities. We will be using a sample of the landing page to get familiar with the sections after creating a new project. Every software has a different set of features and utilities. We have shown below a screenshot to illustrate this. Remember, this screen will appear only after you have imported your transcripts into a project folder. The features of this workstation are: 1. Menu bar at the top. 2. Case window, which contains the list of available cases in the project. These cases are displayed either as a list or grouped as a tree. This window is used mainly to browse through cases and select the active case on which to work. 3. Variables window, which displays and allows editing of values for any variable associated with the currently active case. Example of variable could be the age, gender, or years of experience. 4. Codes window, located in the lower left corner of the screen, contains all codes currently defined in the codebook. 5. Document window is the large window on the right side of the screen and is the main working space. This window is used to view and edit documents and images and assign codes to text segments or image areas. The document that is to be coded is opened in this window by clicking the desired document icon in the project folder. When a case contains more than one document or image, you can switch between them by selecting the document image tab located in the top left corner of this window. 6. To the right of the document window is an area used to display the codes assigned to text segments and image areas. A second area is displayed below the images. Colored brackets are used to indicate the physical limits of the coded segment. This area is used to review coding, remove or change assigned codes, and attach notes to any coded segment. Figure 3, the workstation. Analyze menu bar, case window, variable window, code window, area showing codes, cutter area, document window. Creating quotations in text documents. This is the process of selecting interesting segments of data relating to the phenomenon under study. Once a quotation is made, it can be retrieved or reviewed later. This is typically done when the researcher is perusing the data and getting a feel of it. One can name the quotation and add description in memo on the quotation. This is like working on a whiteboard canvas in pen and paper setup where the researcher would typically place post-it notes defining or describing the code that will go with the quotation. The researcher may choose to code the quotations right away, but should steer away from this pressure if the codes are not ready. It is advisable to come back to coding quotations once a bird's eye view of the transcripts is captured. Coding is the strategy that moves data from diffuse and messy text to organized ideas about what is going on. It is the assignment of conceptual tags to segments of information that are of interest to the research objective. Ultimately, these quotations and codes will shape the framework which will scaffold the theory emerging from the project. Its importance cannot be overstated. Coding can be done by various attributes, but the thing that remains the same is that all quotations labeled with a particular code share a commonality. The common denominator is dependent on the research question, and there are no set guidelines for it. For example, selecting a paragraph about water quality and coding it at the node water quality. Node is the word used by the software to denote a container for the codes. Steps to follow. 1. Select a phrase or word that you would like to code. 2. Go to the top menu bar and press Code, right-click. 3. Drop-down menu shows Create Code or Add Code. When you click on that, the following dialog box appears. Figure 4, Coding window and its description. Menu bar, name your code, name the category under which your code comes, describe your code. Once this is done, the new code will show up in the code box under a specific category. In the color area, there will appear flower brackets at the spot where this code is quoted. The next time when you want to assign the same code, select the area of the graphic text you want to code and double-click the code in the code list. Here is an example. We have interviewed 5 students. We asked them to express their views on what they think are the qualities of a good teacher and the skills required for effective teaching. One of these interviews is coded as shown below. Figure 5, document view showing codes. After all your coding is done, it is advisable to go through all your transcripts and have a rethink on whether you would like to merge, delete, change category, or edit your codes. If so, you need to click on the code button and select the appropriate action from the drop-down menu shown below. Figure 6, common operations available for codes. A priori and emergent coding. The researcher can prepare a skeleton of codes even before starting the qualitative data collection. Superficial codes pertaining to chief socio-demographic factors are examples of codes that can be present a priori. Sometimes the researcher anticipates some conceptual connections in the resource documents and creates codes beforehand to label when these connections are spotted. Emergent coding is the more classical approach where codes are generated after the researcher has completed feeding the data. It might be worth reiterating that coding can be skipped until a significant number of transcripts are read, else one runs the risk of generating too many codes without any thought-out function. Grouping codes. The process of grouping codes is remarkably like that of grouping documents. In addition to being used as local filters and global filters, code groups are also used in the code document table discussed later in the chapter. Merging codes. If one ends up having too many codes or would like to combine granular codes together to a higher abstract level, one may merge codes. Sometimes two codes will share a similar meaning and can be merged. Categorizing codes. Categorization is simply the process of reviewing everything that is coded and then creating code categories that can be used to guide future analysis. In other words, it is about creating categories for the set of codes. A practical example could be as follows: if different types of animals in a particular habitat is the topic of the interview, initial codes may be monkeys, snakes, and lions. During categorization, the categories could be reptiles, amphibians, or mammals. This helps the data to be more organized and enriched in that new connections are generated between different groups of codes. The codes also go from specific to general. The next step is to identify the themes in the data. Theme identification, theme generation. From categorization emerges the themes. The coding and categorization processes will reveal the theme of the narrative, and therefore the next step would be to identify the themes in the dataset. When determining themes, the coding and categorization must be kept in focus and one should logically flow into the other eye, from codes to categories and onto themes. If we take the above example, we could say that an emerging theme from the above would be the fauna in a particular habitat, and another theme that could go with it could be flora, although not described above. This is how meaningful inferences and conclusions can be drawn from data. The inferences that are drawn would be crucial in generating a report or a narrative from the data, and the nature of which will depend on the research aims and objectives. This narrative should be able to answer the research question that was posed at the beginning of the qualitative study as explained in the previous chapter. Querying the data. After the coding is done, the next step would be to query the data or analyze it. In the software top bar, there will be a button which says Query or Analyze, which will give a drop-down menu for a lot of query or analysis options. Some of the data querying tools available in QDA software. Coding frequency. This is a simple table showing the frequency distribution of the applied codes in the document. Figure 8. Frequency distribution table of codes applied. Code document table. It is a cross-tabulation of codes or code groups within documents or document groups. It depicts the frequency of occurrence of a code in a document or document group. Figure 9. The code document table. The Sankey diagram. This is a visual representation of the code document table. The rows and columns of the table are presented as the nodes and edges in a Sankey diagram. Each node on the diagram represents a number in a cell of the table. The thickness of the node is proportional to the co-occurrence frequency. Figure 10. The Sankey diagram. Let us study the Sankey diagram shown above. It shows us the co-occurrence of two codes with 5 document groups. The darker line adjacent to the names of the codes and documents is the node. The thickness of codes shown on the left is almost equal. This is because the document groups mention these two codes with approximately equal frequency. From the diagram, it can be inferred that the documents generated from couples having 3 children were least, and most documents came from imported survey data. Finally, the number on the band between two nodes shows the numerical frequency of the co-occurrence of the two entities. Code co-occurrence analysis. If you have a reason to believe that 2 or more codes will occur simultaneously, then this can be further explored by the code co-occurrence analysis. It also sets the stage for interesting chance occurrence findings. It presents results for codes that have been applied to same quotations. This is useful when there are passages that have content that is thematically in close proximity to others. Like the code document table, a Sankey diagram for code co-occurrence is also generated. Word cloud. Word cloud is an interesting method to depict the frequently used words in the transcripts. Words with the maximum frequency revolve around the central theme of the research. A flip side of generating word cloud is the frequent usage of articles such as a, the, is, was, etc., which invariably are the most frequently used words. To suppress counting of these words, a stop list can be given to the software. All words entered in the stop list will be excluded from being measured. The cloud can be exported as an image file to be used in other documents. Figure 11, a word cloud generated in a TLAS.ti. The network. The network is the most analogous to the whiteboard work of a qualitative researcher. It gives the flexibility of plotting codes, documents, quotations, and memos in a visual landscape. It may be intuitive for representing complex relations by graphical means. Once a blank network is created, elements to be visualized in the network can be added by simply dragging and dropping them on the workspace. Each entry on the workspace is now a standalone called as a node. The nodes are connected to form a network. To do this, select the node to be connected. A white dot appears on the left side of it. Drag and drop this dot on the node to be connected and select a relation between the two nodes from a drop-down list. Figure 12, connecting the nodes in a network. Creating a report. After the analysis and querying comes the final step of creating a report which answers the research question. Keeping this in mind, the researcher can choose to represent the data in the various forms described above, namely a code frequency table, a code document table, a Sankey diagram, a word cloud showing predominance, a network showing relationships, etc. Besides these analytical features that have been described above, there are several others depending upon the software used. Whatever may be the analytical or querying tool, it should adequately answer the research question. Summarize. The three stages below summarize the principles of software use in qualitative data analysis. Stage I. Download software. Some are paid, others are free to download. Create a project folder in the software. Name the project. Import all your data into the software. Check the support system of your software. Stage 2. Understand your workspace. 1. What each section represents. 2. What are the icons in the top bar. 3. What are the functions that you can perform using both the above. Stage 3. Read your transcript. Create quotations. Create codes. Quotations will help create codes. We read codes with the transcript. Is all the data coded? Is there any overlap? Merge codes, add codes, change the code organization. Coded all text adequately. Analyze. There are different ways to analyze. Keep in mind your research question. Create report. Does report answer research question? Evaluate. Ponder on the following questions. These will help strengthen the use of QDAS in your own qualitative research. In your own work as a researcher, have you ever felt drowned by qualitative data and wished there were more assistance? Have you avoided conducting qualitative research because of challenges with data analysis? Reading the chapters on qualitative data analysis and QDAS, do you now feel more confident about your ability to deal with this arm of research? Please give us your feedback as well as your suggestions on how we could help you.